Friends, another very important aspect of solving questions in trigonometry is the use of 1 in trigonometry. Now you wonder that it is such an absurd question. Use of 1, we all know what is 1, correct? 1 can be used anytime as it is, but it's not like that, my friends. We have to be very judicious in using 1 in trigonometry. Many times when we do not know how to use 1 in trigonometry, we get stuck up in many situations. And if you know how to use 1 in trigonometry, you will see that the questions which are based upon proof will become very simple for you. Now let us see how 1 can be expressed in different forms, in different ways. The first one can be written as, in trigonometry 1 can be always expressed as sine square theta plus cos square theta. You will wonder, sir, how come we got this? Remember, we had got the identity that sine square theta plus cos square theta is equal to 1. So why can't we write 1 as sine square plus cos square? Correct? Justified? So if we can write sine square theta plus cos square theta is 1, then we can always express 1 as sine square theta plus cos square theta. Then similarly we can write 1 as sec square theta minus tan square theta. You will wonder how we got this one. So we got this from here. If you take this tan square theta from LHS to RHS, this plus tan square theta will become minus. So you will get sec square theta minus tan square theta, and 1 is where it was on the LHS. So 1 can be expressed as sec square theta minus tan square theta. Similarly, now you must have got an idea that we can express 1 in the form of cosec square and cot square in this manner, that we can write 1 is equal to cosec square theta minus cot square theta. Correct? So these are the three basic ones where we can express 1 in the form of other trigonometric ratios. Now I wonder, sir, what are the other ways of writing 1? The other ways of writing 1 are, that if I write like this, Abbas upon Abbas, that is if I divide one term with the same term, you know what I get? What I get? It gets cancelled and we get 1 only. Similarly, if I divide, say 1 plus sine theta with 1 plus sine theta, don't they get cancelled and we get 1? That means in mathematics, whenever we multiply and divide with the same term, same quantity, same number, we always get 1 because both the quantities get cancelled and ultimately the result is 1. Clear? Now you will wonder, okay, sir, what is now the last way of writing 1? What is this one? We know, friends, that anything when written as a power 0, that is anything raised to 0. For example, if it is a raised to 0, or it is b raised to 0, or it is x, y, z, the entire bracket raised to 0, or it is tan theta raised to 0, or anything raised to 0, its value is going to reduce to 1. Correct? So these are different ways of writing 1. Understood, all of you? Now coming on to the next part of our discussion, that is, you will see now in the coming few minutes that how I convert these 3 identities into 18 identities. 3 identities into 18. Don't worry about the fact that you will have to remember then so many identities. Not like that, my friends. You will see that by making certain very small changes in these 3 identities, I will get 18 identities out of them. Let us see how. Let us count one by one. First 3 identities you can see. 1, 2 and 3. The first one is sine square plus cos square 1. First identity. Second identity is 1 plus tan square equal to sec square theta, and the third one 1 plus cot square theta is equal to cosec square theta. So 3 identities are there in front of you. So how many identities? 3, right? Now I will convert them first into 9. See how. I can keep cos square theta as it is on the LHS and shift sine square theta from LHS to RHS. I will get 1 minus sine square theta. Hence, I got another identity. From the same identity, I made a new identity, that is cos square theta is equal to 1 minus sin square theta. Friends, I know what you must be thinking. You must have got an idea that now what I am going to do, I am going to keep sin square theta over here, and the next one is of cos square theta. So take cos square theta there, you will get 1 minus cos square theta. Correct? So how many we got now new? We have got two new identities, right? Same way here also. You can keep tan square theta over here and take 1 on that side. So this will give me tan square theta is equal to sec square theta minus 1, or you can keep 1 over here and take tan square theta there. So you will get sec square theta minus tan square theta. Correct? So we got two new identities. From the same identity, we got two new identities. Friends, I know that you are feeling very happy in yourself, that you know how you can convert this into two more. You know what you are going to do? You will take 1 over that side, you will get cot square theta is equal to cosec square theta minus 1, and keeping 1 over here, you can take cot square theta that side and you will get cosec square theta minus cot square theta. So now let us count how many identities we have got. Remember, I have promised you that I am going to convert 3 identities into 18. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, where are the other 9 identities? And this is a very, very interesting thing that I am going to show you, my friends. Listen to me very carefully. You know, in every sort of sport, for example, in football, in hockey, in volleyball, in badminton, even in cricket also, you know, after every particular time, they change the sides. See, after first half, in football also you must have seen that they change the side. The red, if the red and blue are against each other, then the red will go from right to left, blue will come from left to right. Remember? In the same way, now I am going to change my side. See, how I am looking at the identities from this side, I can say, I am seeing sin square plus cos square is 1 from this side. I am seeing cos square is equal to 1 minus sin square. I am seeing sin square to 1 minus cos square. Correct? So, all these identities from this side, I am looking from LHS to RHS. Correct? That is, I can always write cos square as 1 minus sin square. I can always write tan square as sec square minus 1 and so on. Now, I will change my side. I will come this side. Now, see, the entire scenario has changed. Now, I am looking from RHS to LHS. So, I get 9 more identities. See what? I get 1 is equal to sin square theta plus cos square theta. So from RHS, my identity is shifted to LHS. I can write 1 minus sin square theta as cos square theta. I can write 1 minus cos square theta as sin square theta. I can write sec square theta as 1 plus tan square. I can write sec square theta minus 1 as tan square. I can write sec square theta minus tan square as 1 and so on. So all the identities which were applicable from LHS to RHS are now applicable from RHS to LHS. So 9 identities from LHS to RHS and 9 identities from RHS to LHS. This makes the total number of identities as 18. 9 from LHS to RHS and 9 from RHS to LHS. In this way, as I had promised my friends, that using only 3 identities, I will convert them into 18. But remember friends, this is no joke. Don't consider it as a joke. It is very serious, because many times you will see that we are going to apply the identities from LHS to RHS or from RHS to LHS. In fact, not only in trigonometry friends, in all the identities that we had learned earlier, in every case we can always go from LHS to RHS and RHS to LHS. In this way friends, we have completed this segment of our discussion. I hope that you must have enjoyed this segment and you are now ready, well equipped to solve questions in trigonometry. Thank you my friends. Take very good care of yourself.